And good morning, my colleagues. I hope everyone is well at 5 o'clock in the morning on a Wednesday. It's 34 degrees out there, and it's chilly this morning, if I may say so. So I want to pick up here where we left off. And this is basically changing our required returns. So the chance that a bond's required return, now this is the return that's going to vary because market conditions or other conditions may have changed, right? So we're going to talk about interest rate risk, right? So you buy a bond at a certain coupon rate, but something happens in the economy or with the company, and interest rates change, and maybe they go higher. So if you would have bought it and waited, you would have had a higher coupon. Or you could have even got a lower coupon, which you would have said, okay, glad I bought it now. So bondholders are typically more concerned with rising interest rates because, and I'll highlight that, an increase in a bond's required return causes a decrease in its price, right? So you bought a bond and the interest rates went up and now your bond is less valuable. Does that make sense to everybody? It's got less value. So the shorter the time until a bond's maturity, the less responsive is its market value to a given change in the required return. So to put it really in context, shorter maturities have less interest rate risk than longer maturities with all features, when all features are the same. So this is very, very important, and I'll highlight that. All right. This statement proves true because of the mathematics of time value. The present value of cash flows arriving in the near future change far less than the present value of cash flows. So, anyway, there's a great video here, and I'm gonna try to play this for you. However, I got to keep the speaker low because it's early in the morning. And I'll put the microphone close to the speaker, okay?
Earlier in this chapter, we discussed the idea that riskier investments have to offer higher returns compared to safer investments. For example, we noted that corporate bonds offer higher returns than treasury bonds, and speculative corporate bonds must offer higher returns than investment-grade corporate bonds. The general principle is that if the entity that issued the bonds is less creditworthy, the bonds have to pay a higher risk premium. But there is another factor that influences the risk of investing in bonds, whether the bonds in question are treasury bonds or corporate bonds. That factor is called interest rate risk, and it refers to the effect that changes in market interest rates have on bond prices. In general, increases in interest rates cause bond prices to fall, while decreases in interest rates push bond prices up. Because movements in interest rates are hard to predict, changes in bond prices are also hard to predict, and that makes investing in any kind of bond, even a treasury bond, risky. Some bonds are more sensitive to interest rate risk than others. One of the most important characteristics that determines how sensitive a bond price will be to interest rate fluctuations is the amount of time remaining before the bond matures, that is, its time to maturity. For example, consider the bonds issued by the Mills Company, which pay a 6% annual coupon. Suppose these bonds have 8 years remaining before they mature. If the market's required return is 6%, then the Mills bonds will sell at par value, or $1,000. But suppose there is an upward movement in market interest rates, and the required return on the Mills bonds jumps to 8%. Discounting the bond's cash flows at a higher required rate of return will reduce the price from $1,000 to $885, about an 11.5% decrease in price. Conversely, if market interest rates fell from 6% to 4%, the bond's price would increase from $1,000 to $1,135, a gain of 13.5% in price. Now consider what the effect of a change in interest rates from 6% to 8% would be if the Mills bond had only 3 years remaining before maturity. In that case, the interest rate increase would cause Mills bonds to fall from $1,000 to $948, just a 5.2% decrease. Similarly, if interest rates fell from 6% to 4%, the price of the Mills bond with 3 years remaining before maturity would rise from $1,000 to $1,055, a gain of just 5.6%. So the general lessons here are, 1. Bond prices move in the opposite direction of interest rates, and 2. The change in bond prices caused by a change in interest rates is greater if the bond has more time left before it matures.
So that was a good explanation from your textbook in that little video, and it reiterates what I said. All right, so the next thing I want to discuss with you is the yield to maturity. And it's one of the different measures of your bond's return. So this is the compound annual rate of return earned on a bond purchased on a given day and held to maturity. Okay, so that's important to know. So it's the discount rate that equates the bond's market price to the present value of the cash flows paid by the bond to investors. So the bond's yield to maturity is basically its required return, which we've been talking about under a different name, right? It's not yield to maturity. It's we were talking about its required return. So the assumptions are that the bond is going to make all scheduled interest and principal payments, and so just so you know, as we already know, if the bond is flat and it doesn't move from its par value, the yield to maturity will always equal its coupon rate, okay? It'll always equal its coupon rate. So, and as the bond prices move, the yield to maturity will differ from the coupon rate. Now, it's not easy to calculate yield to maturity by hand. So, what you're going to have to do, and even they say it here, solving for R, the yield to maturity is algebraically is difficult. So usually we use a calculator or basically a spreadsheet, Microsoft Excel. Okay. So here is the personal finance example with a calculator, and here it is with a spreadsheet. Okay. And so they show you two ways of doing it, by entering the data year by year and using internal rate of return. Okay, so there's two methods to do this here, right? Or you can basically use the rate function, because you'll notice this is an annuity. Okay, this is an annuity here. So you can go two ways with this, all right? So it's important to understand how this is the internal IRR function in Excel, or you can use the rate function, and here's the inputs for that. So that's an important consideration. All right. So here's a summary on everything we did in this chapter. So interest rates and required returns embody the real cost of money, inflationary expectations, and issuer risk. So we'll highlight that. They reflect the return required by market participants, right, as compensation for the risk perceived in a specific investment. The interest rate or required return on a bond varies with the bond's maturity, and typically rates are higher on long-term bonds. So the yield curve plots the relation between the required return and the maturity of bonds, and that's again usually for treasuries, right? For treasuries. So the financial manager needs to understand how to apply valuation techniques to bonds, stocks, and tangible assets to make decisions that are consistent with the infamous term shares price maximization goal. All right, so I believe that's the end of this chapter. All right, so next time we meet, we will move on to chapter 7 here. I hope everyone has a good day.